Hello and welcome to an introductory tutorial in ANSYS Workbench 18.1. In this tutorial we're going to look at the stresses that develop around a hole in a thin plate. We're also going to give an introduction to ANSYS Workbench. So after opening ANSYS Workbench, you have this top row of menus that you can click on. Under File, you'll save, you'll import, you'll export a report, and you will use the export report in this class. View, just your basic typical view where you can view toolboxes or not. Tools, there's no tools listed yet. Once we get going in the model, some tools will become available. This essentially talks about our licensing right now. Units, you want to check your units all the time in ANSYS Workbench because they can be anything that you pick, and the defaults might not be what you think you want. So you need to check your units often to make sure you're using the right units. Extensions, this is where you can load up external code that's been written by other third-party people and use it to run like a fatigue analysis or another analysis that is not built into Workbench. Jobs, this is just to help you monitor your jobs, and then the help. Over here you have some save options. Here you can start a new project and various save options. Down along here you can import a project or open a project that's already existing. This ACT start page is how you will start to use extra extensions. In the toolbox window you have analysis, systems, component, custom, design, and external. Typically you're just going to use analysis systems. If we open the drop down there, we can see all these analysis tools. We will typically use static structural, but we will also use eigenvalue buckling. In the course of your studies you will likely also use a modal analysis, a random vibration. We'll use topology optimization in this class, and if you need to do some transient analysis you can use these. On component systems, this is similar to analysis systems, but it's individual parts of the analysis systems. We won't use any of these in here, except it would be possible to use the geometry. So we could use the geometry and we could use the mesh, but other than that we won't use anything in this section of the toolbox. In terms of custom settings or custom systems, we won't do anything with these, so you don't need to worry about what's in there. In design exploration, this is where we will do our optimization. We'll both do a direct optimization, a parameter correlation, and response surface optimization. So we'll get familiar with the tools in this drop down. To begin this model with, we're going to use static structural, and so I can come to static structural and either double click with my left mouse button or click and drag it into this green square, and it will create a standalone static structural. It comes up with the static structural highlighted here, and this is where I can enter a name. I'll just call it plate with hole, and I can enter that name. Then what I want to do is I want to just work down this pop-up window in order. So the first thing that I'll look at is engineering data, and you can see that it has a green check mark here, and that's because it has set a default of structural steel. If I want to use structural steel, I'm okay to go ahead and move on and create my geometry and my model. If I want to change from structural steel or modify this, I need to double click on it, and I can come in here and see for structural steel, here are the material properties that are being used. If I wanted to change the density or the yield strength or any of these values, I would come in and simply click on that number and change it. So I could click on the 7850 and change that to what I wanted to. In the elasticity, when you click on it, it brings up this table here, and you can change a shear modulus, a bulk modulus, and a Young's modulus. And they can also be temperature dependent. So that's how you use the materials. If you want to select a different material, you can also do that. And that is done by coming up and clicking on Engineering Data Sources. And now I have a bunch of different materials I can pick from here. In General Materials, I'll click on that, and you can see now that it brings up a bunch of different materials. I have structural steel, stainless steel, polyethylene, gray cast iron, etc. Aluminum is a common alloy that we would want to use, and so if I wanted to use aluminum, I would simply click on it and then come over and click the plus, and you can see that it has now put a little book here, which means that has been added. So if I come up to look at the materials that I have available now, I will see that I have aluminum alloy also added in there. And if I want to check on those properties, I just click on aluminum alloy, and then I can come and change any of these values that I want in here. You'll notice that the units are default to pascals and kilogram and millimeters. If I want to change those, I can simply come over and select the drop down and change those units. Once you're done with your material selections, you can simply click the X on Engineering Data and come back to your project schematic. And now we're ready to start the geometry. So I will double click on the geometry, and down here you can see that it's got a red dot, meaning it's working, and it's starting this SpaceClaim package where we will develop our geometry. When SpaceClaim starts, you get this pop-up window where you can scroll through and pick some tutorials or different options in SpaceClaim. You can look at an introduction, a quick reference card, and some other helpful tools that you may want to be able to use. I typically keep this checked to show it startup, but then I usually just close the pop-up window. Now what you do in SpaceClaim is you have what we call a sketch plane, and you will sketch your geometry in the sketch plane, and then you'll turn it into a 3D geometry. And I like to work in the XY axis instead of the default XZ axis. And so what I do is right click and click on Select New Sketch Plane. And now when you move your cursor around, you go into the various planes that you can sketch in. And I like to sketch in the XY plane. And one reason for that is because that's the default plane that will be used in ANSYS Mechanical. So I move to a point in the XY plane and then click on that point. And now that plane has been set. And if I come up to Plan View, it'll rotate that so that I'm looking at that sketch plane head on. I could also come down here and pick any of these to look at the different sketch planes. If I want to change my units, I come up to File, and then I click on SpaceClaim Options. After my SpaceClaim Options window has opened, I go to Units, and when I'm in, I need to click on that again, then I go to Units, and I can change the type to Imperial, and the default there is inches, but if I want to put it in feet and inches or mils or inches, I can go ahead and do that. For this model, I'm going to put everything in terms of inches. Then I need to scroll down and usually accept most of these defaults, but I don't want to look at my minor grid spacing in 1/8 of an inch. I want them to be in 1/10 of an inch. So I'm going to come along here on my minor grid spacing. I'm going to put a 0.1, and then number of grid lines per major, I want 10. So now I can go ahead and click OK there. The rest of these you're welcome to change if you want to. For example, your appearance, details, the different things you can explore around and see what you can do with these options. So I've changed my units. I'm ready to move on, so I click OK. And now I'm ready to start to construct my plate with a hole in it. In order to sketch anything, you need to be in this sketch mode. This mode down here is a 3D mode, and we will be in that mode when we go to pull the structure into a three-dimensional piece. Again, we'll sketch this geometry and then we'll pull it, or extrude it is another word commonly used, into a three-dimensional member. So I'm in sketch mode. I can come over here, and any of these tools right here will help me build my sketch. And so I'm going to build a rectangle, and in this case I want the rectangle to be centered on the origin of my XY. So I'm going to scroll down here until it says define rectangle from center, and I'm going to click on that. Now I'll come to the center, click, and drag my rectangle out, and you can see that it is centered about that centroid of my part. Now I can just go ahead and start to type in a number here where this is highlighted. My dimensions are highlighted in blue, and the number that I want there is I want a 10-inch long plate, so I'll type in 10 and hit enter. And now when I hit tab, or actually after I've hit enter there, it will automatically go to the other dimension. But if I want to toggle between these two dimensions and change them, all I need to do is hit the tab key. So now that the 2.4 is highlighted, I want this to be 5 inches, so I'll type in 5, enter. And I now have my plate. You'll note, however, that when I did that, no longer is my plate centered about the origin, but it simply shifted the plate down to 5. So now when I go to put my hole in the center of the plate, I need to know where that hole is. The other thing I could have done is just undo this with this undo command, and undo again, and then I could click in the center and stretch this out to 5 inches and 10 inches, and then it will remain centered about the origin. And so there I'm 5'2", there I'm 5 and 10 inches. So now I can go ahead and let go of this, and I have my rectangle centered about my origin. Now I'm ready to build my circle, or my hole in my plate, so I'll click on the circle command. I'll come to the center, click on the center, and now scroll out. This particular hole is going to be 0.75 inches. So here in the blue I can either scroll down till it's 0.75, or I can simply type in 0.75, enter. Now I have my hole and I have my plate. Now I'm ready to extrude or pull this plate. With my check mark or my square at my cursor, my T, that means I'm still ready to draw a circle, and the way to get out of that mode is to hit your escape button, and it escapes out of drawing a circle. And if I hit it again, now I'm back to just being under select. If I click on my center mouse button and rotate, this is clicking on the wheel, I can move my structure around. If I want to translate it, I can click the control button and then click my middle mouse button or my roller and translate my structure around altogether. If I want to zoom in and zoom out, I simply need to scroll the roller or my middle mouse button, and I can zoom in and out. You can also come down here, and if you want to look in the X direction, you can just click on the X. If you want to look in the Y, you can click on the Y. In this case, we want to look at the Z, so I can click on the Z. And now you note that it's rotated up. If I click on the Z again, it will rotate my geometry back to how it was. So I'm going to rotate this kind of like this so I can start to see when I pull it. And I'm going to make this 1 inch thick plate. So I'll come up to the pull command, then I'll come down onto the face that I want to pull, and I want to pull this yellow face. You'll note that by default it keeps the hole out of there. If I wanted to pull the hole, I could simply click on the hole and pull it out, and if I go backwards you can see that I'm creating a cylinder. I don't want that, so I'll come and hit undo. I'll come back. I'm still in the pull command, and you can see the arrows, the yellow arrows there are showing me which way I can pull. So I will right click on my structure, pull this out, and I'm going to enter 1 inch. Or you could pull it to 1 inch, but sometimes it's quicker just to enter the 1 inch, and then you get that number exactly. Now I can hit escape, and I'm back to select, and my geometry has been built. There's a lot of other ways that you can use the pull and move. We'll talk about those when we get to more complicated geometries. We can also split bodies, and we'll also talk about those in a future tutorial. I'd like to talk about a couple other things before we leave SpaceClaim, and one of those is the structure tree over here. You can see that I have a solid, and when I click the mouse on top of the solid, it highlights the solid, and you can see that I also have a surface, and that surface is the surface that I had to create the hole. When I go to put this into ANSYS Mechanical, I'm not going to need that surface. So I can right click on it and say suppress for physics, and now it won't transfer into ANSYS Mechanical. The other thing I can do is just simply delete it. So right click and delete it. Now all I have left is my solid. I want to show you a few other things about the geometry. In this region of the sketch tool plane, we can pick items that let us change or modify, edit the geometry. So for example, if I want to, I'll back up to where I just had my body like this. If I want to put a corner in here, what I can do is come to this command. It says create rounded corner. Click on that, and then when I come to click that top surface, I can click that top line, and I can enter in a radius for a rounded corner. And if I do that and enter like a 0.2 radius, now that has been made into a radius value. I can also use a corner, where I can create a corner, and I select the lines. And these other tools also help you edit the geometry and the straight lines and the things that you've already created. So I'll go ahead now and go back to my structure, and I'll go ahead and just pull this out again 1 inch, and now we're ready to move on to ANSYS Mechanical. To do that, I'll come back here and delete this surface before we move to Mechanical. Now I just have the one solid, and I'm ready to go to Sketch. So I can minimize this window, and now I'll double click on Model, and you can see down here it says Starting Mechanical. This can take a second. So once Mechanical is started, you can see that it's brought in the geometry with the hole. Here the axes work a little bit different. You can still click on it and view the part along those particular axes. If you want to look at it in the negative direction, all you need to do is go, for example, here I want to look at the negative z. I need to just go down in the negative z direction, and that would be looking at it in the negative z. So it's quite handy that way. Over here in your project outline, you can click on the geometry, and you have one geometry in there. You have the green check marks, which means the geometry is recognized as a physically correct geometry and can be modeled. Oftentimes you'll need to create a new coordinate system. This is often done when you're using beams or need to look at multiple components. In this bar with a hole in it, we won't need to do anything with our component with a coordinate system. Here we're ready to do the mesh, and what this mesh does is it puts the elements on the model. I can right click on mesh, and I can insert different functions that I want the mesh to have. For example, I could refine the mesh in certain areas. I could pick my sizing. I can pick my method for meshing. I could face mesh this and then extrude it through the rest of the body. So there's lots of options you can insert here. To generate the mesh, you just click on generate, and you can see that this pop-up window comes up, and I have a mesh that has been generated. It's kind of an ugly mesh. It's not a very fine mesh, and so I want to have a much finer mesh around this hole than is shown there. So I actually come to mesh again, right click, insert, and I'll insert a refinement. And now it wants me to pick the geometry where I'm going to have the refinement. This yellow, when it's highlighted in yellow, that means it's waiting for data. It's looking for something, it's looking for an input. So I'll rotate this, and I'll click on the surface tool. Up here you have a vertex select, a line select or edge select, a surface, and then you can select bodies. Here you can select nodes and elements. So I'm going to select the surface, so I'll click on the surface selector. Then I come and click on that inside surface, because that's where I want my mesh to be refined. I come over to the no selection, click on it, and then it says click apply, and you can see that I've clicked one face. My refinement right now is at a level 1. I'm going to click on this line and increase that to a level 2. And now I need to update my mesh. If I click on the mesh to see my mesh, you can tell that it has been changed to yellow, which means that the current mesh is not being shown, and the mesh that is shown is an outdated mesh. So when I click update, it will update the mesh with the new settings. Now you can look at this again directly in the z-axis, and you can see that I have a lot more refinement around that hole. The rest of this mesh still doesn't look very good, so I can come back to click on my mesh, and I can come down here to sizing and open the sizing drop down, and then on the relevance center, instead of having coarse, I can come and pick medium or fine. I'll go ahead and click on medium. You can see I have my yellow or outdated mesh again. I click on update to get an updated mesh. Now you can see it's starting to look a little better. I could probably change that to a fine mesh. As another refinement, I can come here to sizing, and under size function, right now the default is adaptive. If I click the drop down, I can click on uniform, and because this is such a rectangular uniform body, this uniform mesh should improve it. Click update, and now you can see this mesh is beginning to look pretty good. In order to determine stress concentrations, you may want to go to one more level of refinement in this region here, but for this model we'll go ahead and leave it like that. So I just continue on down my outline tree. I have my geometry, I have my mesh. Now I'm ready to apply boundary conditions and loads. So on static structural, you can see that I have a question mark there, meaning that this static structural needs to be addressed. When I right click on it, then I can insert all kinds of things. I can insert loads, from forces to moments to pressures. Then down here I can have my boundary conditions. I can have a fixed support, displacement, cylinder, elastic, and all these other types of boundary conditions. And then I can enter in some constraints as well. I'll go ahead and enter a fixed support on one end, so I'll click fixed support. Now it wants to know the geometry associated with that, so I'll come and I'll click this face and click apply. So that's a fixed support. Now I'm going to go ahead and right click on static structural, insert, and I'll insert a force. I'll click on this face and click apply. Now I'll scroll down on my force, and I only want to have a force in the X direction. So I am going to click on the define by, click the drop down, and define by components instead of vector. Now when I scroll down, these yellow lines again mean that it's waiting for some data. So my X component, I'm going to go ahead and put 100 and then enter. Now you'll note that the 100 that I entered is 100 newtons. And so if I want to keep my units straight, I need to come up here to units and come down to US customary and select inches and pounds. Now you can see that my force was left as 22.48 pounds. So to put a 100-pound load on there, I need to click that and enter in 100. Another indication of that is this shows the units here, and you can see that it is now in pounds force, where before it was shown in terms of newtons. And that's why I say you need to be careful to check your units all the time. It's a good habit to get into, to as soon as you bring up mechanical, check the units. Now I have my force applied, I have my boundary condition applied here in the back. I'm ready to go ahead and solve this. So I'll come to the solution and I will click on solution, and in ANSYS Mechanical you have to select the outputs that you want. So I can either right click on solution, insert, and insert stresses and all these kinds of stresses, or under solution these things are also shown up here, and I can, for example, click the drop down on stress and enter an equivalent stress. I can enter in a normal stress. I could enter a maximum principal stress. I can come to my strains and show the various strains. I can come to a deformation and enter a directional deformation. And then down here in the directional deformation details, I need to come and select the axis that I want. In this case I want the x-axis, but if I wanted the y, then I just click the drop down and click the y. Now you can see these lightning bolts. What these lightning bolts mean is that data has been entered and it's waiting for a solve command. So I can go ahead and right click on static structural and then click on solve. I have attained a solution now, and I can tell that by the dialog window for the solving that closed up, and then I have these green check marks by the various outputs. So I can look at the equivalent stress and rotate this around, look exactly in the Z direction, and I can see if those stresses make sense. I can rotate it to look inside and see that it's uniform throughout. I can look at the normal stress, maximum principal stress, and the directional displacement. these are the values then on the equivalent stress or normal stress that I want to compare with the actual answers that I get in my hand calculations using the stress concentration factors in the back of your Shigley textbook. So to probe the actual values for the stresses, instead of using the bar chart, you can come up and click on Probe. And now you can go in and pick any node that you want and compute the stresses. You can see in this area here that my stresses are around 63.47, 63.7, 63.1, 62.7. So I'm right around 63.7 or 63. And I can use that to validate my stress concentration factor in the back of the Shigley textbook. Here I have done that. I have a 5-inch wide plate with a 0.75-inch hole in it. So my nominal stress is that force, 100 pounds, over the area with the hole in it, which would be the 4.25 times by 1, which gives me 23.5. Now when I scroll down and I look at the KT plot for a bar with a hole in it, the D over W that I have is D is the diameter of the hole, which is 0.75. W is the width of the plate, which is 5. This gives me a D over W of 1.5. If I come in here at 1.5 and go up to the line, I'm real close to 2.6 for a stress concentration factor. If I compare my hand calculation stress to the ANSYS result, I get 6304 for the ANSYS result and 23.5 for the nominal resolution, and that gives me 2.47. So to determine the stresses at a particular node, you can come up and click on Probe and then All Bodies by default, and as you scroll through your model now, it gives you the stress values at the various nodes that you select. So you can see that I'm right around a 63.0, there's a 63.4, there's a 62.9, 63.04. So I'm right around 63 as a stress value. So I can take that value and use it to determine my stress concentration factor. So I was given a bar of 5 inches in width and a 0.75 inch diameter hole. The nominal stress for this situation is calculated by sigma equals F over A or P over A, where the A is the area with the hole included. So I'll have a 4.25 vertical and a 1 inch width or depth into the board. That gives me a 23.5 for a stress. If I come down here now and look at my stress concentration table, I have a D over W where D is the diameter of the hole, 0.75, W is the width of the plate, which is 5. It gives me a D over W of 0.15. So going into my table at 0.15, I come up and I come across and I'm right around a 2.6 for a KT. Now I can also compute the KT by comparing my ANSYS result, which was 63.04, to my hand calculation result, which was 23.5. Taking that ratio, I get 2.68. So the 2.6 and the 2.68 is a very good comparison between the two calculated stress concentration factors. So I hope this has given you an introduction to ANSYS Workbench, and we will continue with several more tutorials, and I hope you enjoy the software.